All right, good afternoon, everybody. It's Monday, April the 6th. It's about 2:30 p.m. and I'm coming to you from my kitchen. I got Yoda here. Hello, Yoda. And Luna's here somewhere, the dog. But what we're going to do today is an experiment on static electricity. Hopefully you guys have been able to see the brain pop video that I assigned on Seesaw. But if not, we're going to watch that now together, and then we're going to talk about it a little bit together, and then we're going to do an experiment with some balloons on static electricity. Okay, so I started watching this a little bit already, but I'm going to, start the video now.
Ow, why'd you do that? Oh, thanks, I guess. Dear Tim and Moby, why do I sometimes get zapped when I touch a doorknob? From Sarah. That's an example of static electricity. Electricity is when electrons, the negatively charged particles in an atom, move from one place to another. In current electricity, the kind we use for power, there's a steady flow of electrons along a circuit. In static electricity, like lightning and those pesky doorknob shocks, there's usually a single sudden transfer of electrons from one place to another. In order for that transfer to happen, you have to have a buildup of electrons on a surface. Hey, what are you doing? Right now, Moby's building up an electric charge. The rubbing makes the balloon pick up electrons from my hair, giving it a negative charge. Because my hair loses those negatively charged electrons, it gets a positive charge. And the negatively charged balloon attracts the positively charged hairs on my head. Because opposites attract, right? I think it looked better before. Anyway, all the matter in the universe is made up of atoms. And every atom contains a certain number of protons, neutrons, and electrons. Protons have a positive charge, and electrons have a negative charge. Neutrons don't have any charge at all. So, when an atom contains the same number of protons and electrons, it has no overall charge, and it's considered neutral. Protons and neutrons are stuck in the nucleus of the atom. But electrons orbit the nucleus, kind of like the moon orbits the Earth. And electrons like to move around. In fact, if you rub two non-conductive materials against one another, those electrons can jump from one material to the other. What are non-conductive materials? Well, conductors are materials that electrons flow through easily. Metals are good conductors. Non-conductive materials, or insulators, don't allow electrons to flow through them. They include things like cloth, rubber, and plastic. Some insulators like to give up electrons, and some of them like to collect electrons. Most carpets are made of nylon and wool. Those substances tend to give away their electrons, leaving them positively charged. Your shoes, on the other hand, have rubber soles, and rubber is a material that naturally collects electrons. Remember how the rubber balloon pulled electrons away from my hair? Well, your rubber soles can pull electrons away from the carpet. All you have to do is walk across it, and the electrons will be pulled out of the carpet and onto the soles of your shoes. A force called adhesion is responsible for the transfer of electrons. You can build up a bigger electric charge by rubbing your feet against the floor. The more you do it, the more electrons your shoes will collect. Anyway, those electrons that your shoes pull away from the carpet stay stuck to the surface of your body. And if you touch a conductor, like a metal doorknob, the electrons will flow out from your body and into that conductor. And they'll do it really, really fast. The shock you feel when you touch a doorknob is millions of electrons flowing between you and the knob in like a split second. That's a lot of energy to transfer in a really short time, which is why shocks can be painful. So, if your home has carpeting, be careful when you're wearing shoes indoors. Right, Moby? Moby? Well, at least no one can see my hair now.
Okay. Let's not do the quiz right now. I'm going to stop sharing